Yes, you didn't tell me your name. What's your name?
Oh, my name is Akonao.
Akonao.
Mm.
Okay. Uh, is the screen sharing there?
No.
The screen is not sharing.
Mm.
How about now?
It's not nothing. Oh yeah.
It's better now.
Mm.
All right. So now we are at projectile motion. So we are going to pick an example there for today, which we are going to work on. Then later we can go to organic molecules, isn't it?
Mm, mm, mm.
What are you doing now at school? What did you do today?
Rate of change.
The rate of change, equilibrium constant. Are you calculating it now? Did you calculate?
Not really. We're not there. We're still in rate of change. The introduction, the
Or
product, and the reactants.
enthalpy of products minus the enthalpy of reactants?
Mm.
Okay.
Yeah.
Yep.
And the activated energy.
And what else?
Activation energy and activation complex.
Yes, the activation energy and activated complex where products are now being formed.
Mm.
Mm. And the activation energy, the minimum energy required.
Mm.
So let's do the projectile which you requested for now. Then if you have pushed the rate of reaction, then we can continue with that.
Yeah.
Okay. On page 63. I guess you are writing somewhere. You have somewhere to write, isn't it?
Mm, mm, mm.
Take long. They take long to play. You'd rather write somewhere fast, it's better, faster. Where you need to catch up, then you can use a video. Okay, so you can't rely on a video recording. So you rather write. Mm. So let's just discuss these ones, which we are having here. So a vector between vectors and the scalar. What is a vector quantity? These are multiple choice questions. A vector
Vector is direction.
magnitude and direction, isn't it?
Yes. The scalar doesn't have a direction and
Yes. So we must know these things. What is velocity? Must be able to define velocity. Rate of change of what?
of it's not a motion. It's a form.
Displacement, isn't it?
Vector.
Rate of change of displacement. Then acceleration is the rate of change of velocity. That's how you define the rate of change of velocity. Then that is change. Velocity is the rate of change of displacement. So displacement, it has a direction. You moved 50 meters. In what direction? To the right. Then the
Mm.
displacement to be positive. So it is a direction. Displacement is a direction. But position does not have a direction. Okay.
Mm.
See the difference?
And also acceleration is its direction.
It's a vector. Velocity is a vector. Displacement is also a what? A vector. But position is not a vector, it's just a scalar. We are just standing at 50 position, 50 meters. But when you move in a certain direction, that is displacement. Did you move to the east? So you must know your compass. This is your east. Or did you move to the west? It's displacement. 50 kilometers north. How many to the south, etc., isn't it?
Yes.
That is your prior knowledge, which you must know from. We are just recapping before you have the problem. So it's just few notes which you must just put down. And these ones, I know you have them in your textbook, but let's just discuss them together. Where you want to add, you can add your input. So free fall, when they say an object is in free fall, it means that
Motion when the only force on the object
is what?
on the object is the gravitational force. Oh.
Free fall, when gravitational force is the only force acting on the object. Gravitational what? Force. That is free fall. That is the gravitational force that is acting on the object. That is free fall. When it is acting, there are no any other forces. The object is just going downwards, which means it's in free fall. Just experiencing mass, object of mass m is just going downwards. Free fall. No other external forces. No air resistance. It's just free fall. Let's go to D. Distance. Total path traveled. There is no direction for distance.
It's a scalar.
Yeah, it's a scalar, which means you are adjusting the distance around the shape or the distance. There's no direction. You're just calculating. If it's 1 meter, and then the other one 7 meters, 4 meters, 3 meters. So there's no direction, just a scalar. For distance, there's no scalar. And then displacement. What is displacement?
Just I think it's in the position.
It's the position
In a space, difference in position. Younger, I think it's the difference in position.
in space. So when you move, for example, point A to point B in a certain direction, for displacement, it must have a what? A direction, isn't it? So space, which means space which you have with a 2D, three-dimensional. For example, an object is moving in space, traveling towards east, like what I was telling you, from south to what? I mean, from south to north, upwards, in a space. The space which we are having, two-dimensional, 3D, the space. So the difference in position, space, which is also correct. What about speed? What is the difference between speed and velocity?
Speed is the distance traveled per time. Velocity is the rate of position. The rate of displacement.
Yeah, using this formula. You use this formula if you still remember that triangle.
Very
Distance is equals to what? Speed times what?
Speed is
So if I want speed, it's distance over time taken. How do you use that formula? If you want D, you are going to say D is equals to speed times time. That's how you interpret the formula, speed times time. So if I want speed is equals to the D becomes the numerator, then the time,
of C.
the total distance. So speed is D over T, like that. So where are they getting the total distance? This is the D, the total distance. Total what?
You mean what? Total time.
T, yes. So speed is distance over time. So the distance per means divided by time. Any question?
I know.
Correct. Then for speed, we said it's a scalar. For example, you can write 10 meters per second, but you do not write
Direction.
whether it's to the left or to the right, or whether it's upwards or downwards, isn't it?
Yes.
So speed is that A. So whenever they say calculate the speed, which means they only want the magnitude. But if they say calculate the velocity, you must indicate the direction. Is it towards the left or towards the right? Is it upward, downward? Is it east, west, north, or south? When it comes to velocity, that's when you put the direction. Is it 10 meters per second to the left, or is it 10 meters per second to the right? So that is the difference. Speed is just a scalar, which is the magnitude only, but velocity must specify the direction. Any question there? Right. Let's move on. Acceleration, rate of change of what?
Acceleration and rate of. You said
Change of velocity, yes. Rate of change of displacement position. So position is measured relative to the frame of reference.
a point.
Yes. For example, you can say your position, assuming the frame of reference is 0 here. That is your position. So that is your position. The reference point will be the origin, 0, 0, 5 meters. So it's measured relative to point of reference. So these are just basics you must just know in physics. Displacement, speed, velocity, acceleration, distance, must be able to define it as well. Let's go to we do a projectile question. Last time the one which we did, that one was a 20 what? Last year's question paper for projectile, the one which I gave you.
Was for last fine June.
It was the final one.
Tough.
After that one, you saw it, no?
Hmm.
So in projectile,
And I think like they'll bring. I think on June they bring some questions for final.
yes, they always do like that. So revise more of those. But for today, let's just have the concepts. Then I will give you a question paper after the meeting so that you work on it, so that we discuss during our meeting tomorrow.
Yeah, and if you have the last year, I think I have one for last year. Yeah, I'll check it. But I can send in advance.
Yes, I will send in advance so that we work the motion, the projectile.
Okay.
So these are the equations of motion that we normally use: VF, the ones which we're using today.
Yeah,
And
I
then
have them.
you have this one. So you must know each term, what it represents: VI, initial velocity; VF, final velocity; acceleration,
Yeah,
9 meters per second; change in Y. This is the displacement of an object in the vertical plane. Okay. And then also the time interval, which is your change in T, delta T, which you're referring to delta T, delta Y, is still the same change. So when acceleration is A is negative, which means upward is positive, then you,
I know it's negative.
like what we were doing in that question. So, right, let's start with this one. An object is projected vertically upwards at a speed of 50 meters per second from point A. It reaches maximum height C before returning to the point of release. Can you see? It reaches the maximum height C. So the question is saying the object takes 3 seconds to reach point what?
To the reach point B.
Calculate the velocity of the object at point what? B.
B.
Let's try this one. Right. The vertically upwards, what is it? 50 meters per second. It's V initial, isn't it? That is your V initial from point A. So you are throwing, so this object was thrown upwards, vertically upwards at 50 meters per second from point A. It reaches a maximum height at point C. So you know at maximum height at point C, the velocity is 0. Before returning to its release, to its point of release. So it's before releasing, before it's coming back coming back to A back. So first it goes up, now it's coming back from C to A. The object takes 3 seconds to reach to calculate the velocity of the object at point B.
Means that it's VF
It will be V what? F, yes.
equals to V initial.
So our situation here, it's like, so which means we are now coming from the, my V initial was 50 meters per second. So if I come from initial, I'm going upwards. I the maximum. Now I come back. So at this point, if it takes 3 seconds, what was the VF here? So I'll give you time to try it, this one. Let's try. You tell us what is your velocity at point B, which is VF. Yes, it's correct, VF. Which equation of motion are we going to use?
The VF equals to V initial plus acceleration and delta T. Because we don't have delta Y.
like that, isn't it? Information are you having here?
I'm having the V initial
What is
acceleration
V?
time
V initial is what?
50.
Your V initial is 50.
Mm.
Then what is your
Plus
acceleration?
acceleration I took uh, upwards as positive.
Upwards is positive. That's good. Which means your A is what?
It's negative 9,8.
Yeah, so A will be equals to negative.
9,8.
Plugging it to be plus negative 9,8. Then what is the
10. Is it 3?
3
Delta.
seconds? So multiply by 3.
Mm.
Then what is your final answer?
So my final answer is 20,6.
Positive,
Mm.
not negative.
So yeah, it's not negative, it's positive.
Okay, so let's verify the working. So we have taken VI 50 meters per second because it's upwards, isn't it?
Mm.
And then your final velocity, that's what you are looking for. Acceleration,
Acceleration
negative 9,8
8.
meters. Then what
Mm.
is the change in Y? It's unknown. The final velocity is unknown.
Mm.
Then the time taken,
It's 3 seconds.
okay. Then how are we going to solve it? Then you plug in 50 plus negative 9,38. Then your final answer is 20,6. Can't use the one for change in Y because you don't have the what? The change in Y.
Mm.
So you are correct. The final velocity is what?
Mm. It's 20,6.
It's 20 meters per second. And this velocity which they are referring to, it's here. Can you see B?
I said upwards.
B, when you are going, it was still going upwards. Then
Mm.
D is when it was returning back.
Like
So
that.
it's still going what? Upwards.
Yeah.
Get it, ne?
Mm. So it's downwards or upwards?
Pardon?
D is not
Eh,
is going downwards.
for D, it's now going downwards. So you
Mm.
must, yes, for D, it's on the other path. So it's going down. So B, it's going up. So you must be able to interpret the diagram. So your answer is correct. That one was correct. Okay, it's correct. So let's go. We try another one. So this is, we are done with this one. So calculate the position of the object at 3 seconds, which is point number B. So position is measured relative to the reference. So which means here we are looking for, when they talk of position, they want the change of Y. Whenever they talk of
Oh.
position, remember from our definition, we said position is measured from the frame of what? Reference.
Mm.
So which means there they are looking for delta what? Delta
At
Y. They are looking for delta Y. So that we are saying from here, this is C, it comes, so this is our B. We are here at B, this is our D, and then this is C. So C, this is B, and then this is what? D. This is our point of what? Reference. Then this is what we are looking for. What distance has it covered, this change in y? Can you see? That this distance going from point of reference up to here. This is our change in y. How many meters is this? Just from here there, it took 3 seconds. So that is the change in y. Any questions?
No,
So whenever they said calculate the position, which means its position at this point, at B. So you use that formula for delta what? Delta y. Integral plus vi delta t plus half a delta t squared. V going upwards is positive, it's 50 positive. And then time is 10 seconds, that is the 3. Half a acceleration negative, then you square the time, then you come to the answer. When you add 150 minus 44, it's what? Positive. It means it's above the point of reference. Whenever you see a plus, if your point of reference is this one, when you see a positive delta y, it means it's above the point of reference. When you see a negative delta y, it means it's below the what?
the reference.
Point of reference. It means it's down. It's
So
like a building,
yeah.
like a
So
building.
yeah, our reference is A or B. It's B.
Our reference is A, not B. Point the original, yeah, at the ground level. This is the ground.
It's our reference.
Yes, that's our reference. So from the ground, which is B, from B, it reaches the maximum, comes back to where it was released at B, but in the opposite direction now. It's coming downward. Here it's going up. Any question
If I use the, I wanna try to use this other formula. Now we got 20,6.
for which one?
Like the delta y equals to CF plus V
Yes,
initial over 2 and delta t. I wanna try
yes,
using.
no problem. You can verify the answer. Which formula did you pick?
Yeah, it's still the same. I was using the delta y ne,
Is
equals
equals to
VF plus V initial over 2 times
yes,
delta. It's
yes,
giving me 05,9.
105,9
9
because the VF we calculated it as 20,1.
6.
So when they say a positive answer for displacement indicates that the object is above the reference point, above the reference point. What is the velocity of the object at its highest point C? So the ball comes to rest at its highest point what? The velocity there is what? Zero.
It's the
It is 0 meters per what? Second.
second. So it's final.
That is the final velocity at C, highest point. That's what they are looking for. What is the velocity of the object at the highest point? What? C. So at the
So
highest
it's
point,
from, so it's
0.
from A. It's from B to C.
Yes. From
It
B
means
to C. Mm.
the time is still the same or it's changing.
No, time always change. And we are not given.
Or time
Our,
is not given.
yes, we are only told that from initial to B, that's when it's 3 seconds. from initial to B, that's when it's 3 seconds. Then from there after, you are not told how much.
So I can use. So we need the delta y.
We don't need delta y, we just need that velocity at that point. That one you don't have to calculate. You know from the theory that where the velocity at the maximum height is 0, there's nothing to calculate there. At point number C. C, that's what you are referring to. At point C, you don't have to calculate. What is it that you want to calculate?
I thought, like you said, the delta y.
Delta y, we calculated it already, this one. That's the one which you said you want to make use another method, and you found the answer. So now we're at 1.3. Can you see 1.3?
Yes.
Yes. What is the velocity of the object at point number C? Which is the maximum. The maximum. Point C is the maximum turning point. Always the velocity is what?
There.
0. Then what about the acceleration of the object at point C?
It's not 9,8.
Is it 9,8? Why?
Because the gravity doesn't change. It doesn't change.
But the acceleration is not 9,8, it's negative what?
9,8.
Yes. What made that object to remain there at 0 is because the acceleration due to gravity was pulling it down. So it was constant, which is negative what? 9
9,8.
meters per second squared. It's not just second, but second squared. Or you can write it in terms of exponent to the power negative 2. If you don't want to write it like this, another way of writing it, you write it like this: 9,8 meters per you are dividing, that is the negative, so per second squared, or you use multiplied by second to the power negative 2. Any question there?
No.
It's clear.
Mm.
All right. Then 1.5, calculate the time taken for object C. Calculate the time taken for the object to reach its highest point C. Calculate the time taken for the object to reach its highest point what? C.
C.
The object to reach its highest point C.
F. VF equals to 0.
Calculate the time taken for the object to reach its highest point C.
C. To T.
The initial velocity was how much?
I'm finishing. 1,8.
The time taken to reach the maximum height. So we are here, we want to reach the maximum height. What was the time taken to reach the maximum? The time from A to C, what time did it take?
It's from A.
From A to C. Time taken from A to C. Maximum height.
Uh, I took 50, and it's from A to
The formula which you used first is what?
VF equals to V initial plus A and delta T.
As A delta T. Okay. So your VF is what?
It's 0 because it's maximum.
Then V initial?
I use 50. I thought like it's from B to C.
No, it's from A to C. The V initial is still the same. 50 positive plus acceleration
I took upwards, it's positive, it's negative 9,8.
divided by delta T. So what is delta T equals?
5,1.
Which is equals to 50 divided
9,
9.
you must take 50 there to the other side. It must be negative. Because
What if you take negative to the other side? It will be the same. Whether you divide by negative 50 over negative 8, it still be fine. Even if you put negative, isn't it? We arrive at, or you can also take the positive, this one, the other side. It becomes what? Negative, it becomes positive. Take the negative, take it to the other side. Becomes what? Positive. You divide by a positive number, 50 divided by that. Or you can also still say 50 the other side, then it will be minus 50 over minus 9,8, which you want. You arrive at the same one.
and
Your answer is equals to what?
1,1 seconds or 1,10 if you
What?
want.
Can be 1.
If it's two decimal places, it's 1,10.
Yes, but what is the full answer? You said 50 divided by 9,8 is what?
5,1.
Okay, 5,1. 2 decimal.
Or 0 there.
Oh, so it's just 5,1 seconds.
Mm.
So let's check it if it's correct. So number 1.5. So we are seeing your answer is what? It's correct.
Oh,
Any question there?
yeah. No, sir.
All right. So how long does it take the object to return to point A after being released? How long does the object take to return to point A after being released? So which means the point of release is here,
It's from
goes, comes back. So you must know how to interpret. So which means This is A, your point of release. B, somewhere there is your B. Maximum point, C, comes back to D, then to the ground, back the ground. So they want this T. What is the total time taken?
So total time
From the whole projectile, for the whole projectile motion.
A to A to C, it's 5,10 plus. I
Plus
think
what?
it's five. Is I think it's 5,10
It's for the
cause
whole. What time year? You mean the whole trip, the whole motion.
five five five
Starting,
comma five
starting
comma
from going there, the time
yeah,
is moving. 5,5 is to reach the maximum point only. It's the halfway here. That is 5. Then the other half to be another 5,5. So what is the total?
10,2.
That is what we are expecting there. There's to be 10,2 seconds. Double the time. Can you see?
Mm.
All right. Calculate the maximum height reached by the object. Calculate the maximum height reached by the object. Did we calculate this one?
Right.
Yes.
Mm,
We are
think
looking at this one. The maximum. This change in one. The maximum. You're changing one.
like can we use the time that we calculated from A to
Yes, you can use it. That one is 5, what? 1
mm,
seconds.
we're
5.
talking VF is there. Huh? Yeah, VF is there. V initial it's feet. Delta T it's 5,10.
Hmm.
You can use this on delta Y equals to VF plus V initial over 2 times delta T. 0 plus 50 divided by 2 times 5,10.
Hmm. What is the difference?
Huh, it's 127,5.
And 7,5.
Mm.
So it's correct. Use the same formula.
I use the that one delta Y equals to VF plus V initial over 2 times time.
Like that.
Mm.
So VF, you are having it. V initial, you are having it. And then you have the what? The time, isn't it?
Mm.
So you all arrive at the same what?
And
And all arrive at the same. And this is the one which you used, this one. VF plus VI multiplied by. You can use that one as well, which is correct. All right. This one, is our homework, which I'm going to leave with you. When we start tomorrow, we are starting at 1.8. Was our time almost. So I will leave this one to work it out. Then when we start tomorrow, we start from here. Is it fair?
Yeah. Calculate the time taken from the ocean. So it's from C to D.
Calculate the time taken for the object to reach D.
Is it from C to D or A
No,
to?
it's the whole projectile
So from A to D.
from A to D. That is your homework.
Okay.
We calculated from A to C, but B. This is C. D. So which means they want this time, only this time. Come. And you have been told that this is how many seconds?
Oh, the whole from the whole projection it's 10,2,
Yeah.
and the half it's 5,10. The other half it's 5,10.
But you want this one.
We need the half of it.
So for it to reach D, not for it to reach the ground. So we want this time when it's at D. What is the time T here when it's at D? Can you see it? Because our projectile going like that. So when the projectile is at 0, it's here. When the projectile is at B, it's at time number 3 seconds. When the projectile is maximum, time is 5,1. What is the time when it's at D? And what is the time it returns the ground? So your T, you are getting it from there. This was 3 seconds. The projectile is at what? B. C. This is now D, which is at the same level with what? B.
Okay.
Now it returns this one A. So your homework is calculate the time from there up to there, which means this T here. This we are told it's 5,1. So you already have a hint that this T is more than 5,1 and it is less than what? 10,
10, 10,
between 5,1, after 5,1, but less than what?
10,2.
So we are going to stop here. That is the homework. Let's work it out. Then we'll continue tomorrow from there. So that I can attend to your sister there. I have a meeting with them. Okay.
So yeah, physics.
Yes, for waves and optics, second year physics.
Yeah.
Okay. So then you show me tomorrow when we start.
Okay.
We end here for today. Continue tomorrow.